This lesson will talk about the graph of exponential function. We'll consider a function y equal to a to the power x. We have two types of graph. The first type, this a, when a is greater than 1, this graph is increasing. You can see it is increasing, and then it will passing through 0, 1. Why 0, 1? Actually, when x equal to 0, you can see a to the power 0, then it is equal to 1, so it's here. It is the first case. For second case, when this a is between 0 and 1, that means, for example, 0.1, 0.2, 1 over 2, 1 over 5. If this a is between 0 and 1, then this graph is decreasing like this. Same, it also passing through 0, 1. Same situation with this. So just the difference of the a. Let's look at an example. We can look at question 1. We have a function y equal to 4 to the power x. As I said before, if this a is greater than 1, you see 4 is greater than 1. Remember this one? Then the graph is increasing. So when x increase, y also increase. And for this point P, it is 0, 1. All the time 0, 1. Next, question 2. This time, the graph is y equal to 1 over 5 to the power x. You can see this one is between 0 and 1. So that means it's decreasing. So then when x is increasing, then y is decreasing. You can see it's decreasing. For this point, all the time, it is 0, 1. Okay, now I give you 2 minutes. Try to do question 3 and question 4. Let's check it. For question 3, this time the function is y equal to 0.3 to the power x. So you see 0.3. 0.3 is between 0 and 1. So it is decreasing. So y is decreasing. And this point, 0, 1. For question 4, this time the function is x to the power x. So this number, x is greater than 1. So it is increasing function. For point P, 0, 1. Next, we'll talk about the opposite function. For example, we have a function y equal to 2 to the power x. So this one, 2 is greater than 1. So it's increasing. Now you need to sketch the graph of this one. Actually, it is a mirror on y-axis. The mirror is on y-axis. When this number have a reciprocal, that means 1 over. That means it's not like a mirror. The graph will become like this. So y equal to 1 over 2 to the power x. You see, when 2, the reciprocal 1 over, so it becomes 1 over 2. So it becomes like this. And for example, look at question 6. For question 6, this time the function is 1 over 6 power x. So this number is between 0 and 1. So that means it's decreasing. You can see it's decreasing. Then we'll look at the opposite graph. For opposite graph, that means reciprocal. 1 over 6, the reciprocal is 6. So look like a mirror on y-axis. So the graph is like this. So this graph is y to the power 6, y equal to 6 to the power x. And for this one, 1 over 6, they are totally opposite. Now, try to do question 7 to distinguish which one is C1 and which one is C2. Now we check the answer. When we look at the number, it is 5. 5 is greater than 1. That means it is increasing. So you can see actually C2. You can see this C2 is increasing function. So C2 is 5 to the power x. And for 0.2, actually is reciprocal. 1 over 5 is equal to 0.2. That means opposite. For this one, 0.2 is between 0 and 1. So it is decreasing function. So here. So C1 is y equal to 0.2x. Next, we will consider for different cases. That means for this case and this case, we have different type of graph. So we will see which equation will belongs to which line. Okay, we have a method to prove it. We will suppose let x equal to 1. So for each situation, when x equal to 1, so y is equal to 2 to the power 1, so it's equal to 2. For the second case, when x equal to 1, y is equal to 5 to the power 1. It is 5. So you can see this one is bigger than this one. So let's go back to the graph. So when x is equal to 1, so suppose it's around here, x equal to 1, then we put a line, a vertical line to here. Then we'll see the blue one is bigger than this red one. So that means you see the bigger one have bigger number. So that means the blue one is belongs to y equal to 5 power x. And for the green one is the red equation. You can see it's 2. This one is 5. So there's a conclusion. That means the bigger of the base, the closer to the y-axis. At the same time, the smaller of the base is far away from the y-axis. So let's give an example again. For example, when x and y is equal to 3 to the power x and y equal to 8 to the power x. So we can know that for x1 is closer to y-axis, and then for 3 is far away from y-axis if we compare these two graphs. Next, we'll consider another case when a is between 0 and 1. We have this situation, 0.1 power x and 0.8 power x. So let's do the proof again. This time we will let x is equal to -1, That means around this side. When x is equal to -1, so y is equal to 0.1 to the power -1. When you press the calculator, you can get 10. And for the yellow one, when x equal to -1, so y is equal to 0.8 to the power -1. So when you press the calculator, 0.8 power -1, you can get 1.25. You can see the green one is bigger than the yellow one. So let's go back to the graph. For x is equal to -1, that means here, -1 is here, is around here. For example, -1 is here. Same, we put a vertical line. So you can see the blue graph. This one is greater than this one. So the bigger, so this one is bigger. So that means the blue line, this blue line is y equal to 0.1 power x. And for yellow one, this one is smaller than 10. So this one is 10. And then the one is 1.25. So the red one is 0.8 power x. So let's have a conclusion. When the base is smaller, you see, it's closer to y-axis. When this number, this base is bigger, is far away from y-axis. Next, we'll do an example like this one. For example, we have the graph, two equations. One is y equal to 0.2 power x and y equal to 0.5 to power x. So as I said before, for bigger number is far away. For smaller is close to. Okay. Now you will given 2 minutes, try to finish 8 and 9. Okay, let's check it. We have two equations, 3 power x and 9 power x. So as I said before, the bigger number, for increasing case, the bigger number is closer to y-axis. So 9 to the power x is C2, so it's close to y-axis, you can see. And for 3 to the power x is far away from y-axis, so C1 is 3 power x. Or you can use another method. That means you substitute x equal to 1. So for example, y equal to 3 power x, you substitute x equal to 1, so y is equal to 3 to the power 1, so it's 3. And for second case, 9 to the power x, when x is 1, y is equal to 9 power 1, so 9. So you can see when we put a 9, put a line here on 1, so 9 is here. And then blue is here, 3. So you can see C1 is 9, C1 is 3. So like this. Lastly, we'll check this one. For y equal to 0.4x and then 0.7 power x. So if you remember, the smaller number for this case is closer y-axis. So this one is this one. So you see, this one is closer. And then this one is far away, so it's bigger. Or you can use another method. That means when you substitute, this time is -1. So you see this one, if negative 1, so y equal to 0.4 power negative 1. So 0.4 with power negative 1, it is equal to 2.5. And for y equal to 0.7 power negative 1, it is 1.43. So you can see this one is higher than this one. So higher is C2, so this one is C2, and then lower is C1.